So welcome back, friends. In the last tutorial, I wasn't able to finish the class because of some technical difficulties. So I'm gonna finish the topic and then we're gonna look into some problems. So let's look into this thing which we were talking about, that mechanical energy is always measured with respect to the some reference ground. So mechanical energy at, let's say, at this point, at location 1, with respect to this ground, that will be equal to mechanical energy at location 1, which is equal to potential plus kinetic energy. Now in this scenario, the potential energy won't be zero because we are measuring everything with respect to this ground. So this will be equal to mgh. Again, I'm repeating, I said it won't be zero. Plus half mv square is equal to mechanical energy at location 1. So this is the most important thing which we need to remember, from where we are measuring the energy. What is the reference ground? So let's look into this question. An ideal pendulum, as shown in figure, is suspended with the string that is, I think, oops, let me correct this. No, it's good. Is pulled sideways and released at the highest point of its swing. The pendulum bob is 25 centimeters above the floor. So at the highest point, it is 25 centimeters above the floor. So we always measure the height from the center, 25 centimeters above the floor, and the lowest point, it is 5 centimeters above the floor. So at this point it is 5 centimeters above the floor. The mass of the pendulum is mass given to me, which is equal to 0.250 grams. What is the mechanical energy of the pendulum relative to the ground floor? So mechanical energy is equal to potential plus kinetic energy. That's what we've said. And mechanical potential energy is mgh. So mgh plus half mv squared, which is equal to mass is 0.250 times 9.81 times height given to me is 25. Let's say this is where I'm measuring it, location 1, at the highest point. So this is 0.25, because this is given to me in centimeters. I have to convert it into meters, and kinetic energy value will be 0 because velocity on top at this point will be 0. So this whole kinetic energy will become 0. So mechanical energy at location 1, we will figure out, this value will come out to be, if I do the calculation, 0.66131. That is the mechanical energy at location 1. Now it says, what is the mechanical energy of the pendulum relative to the floor? Because this is an ideal pendulum, so this is a case of isolated system. So mechanical energy at location 2 is equal to mechanical energy at location 1. So I have to specify what I'm calling the location 2 as. So this is mechanical energy at location 2. So at mechanical energy at location 2 will be the same. So the value will be at location 2 is 0.6131 joules. And then what is the kinetic energy of the bob? Let's look into the this is the third part now I'm doing. So what is the kinetic energy of the bob when it is at its lowest point? So at lowest point means at location 2, I wanted to find the kinetic energy. I know the mechanical energy, me at L2 is equal to potential, again same formula, potential plus kinetic energy. So potential energy is equal to how much? It is equal to mgh, and mgh is 0.250 times 9.81 times height is 0.05. 1 meter equal to 100 centimeter. 100 centimeter, remember this thing. So this becomes 0.05 meters plus kinetic energy, which I wanted to find out, and this is 0.6131. So if I do these calculations, I will get the value as the kinetic energy is equal to 0.491 joules. So that will be the value of kinetic energy. So we solved for part C. Now what is the speed of the pendulum bob when the bob is at its lowest point. So for D, I wanted to find the speed. So kinetic energy, this is the kinetic energy at the lowest point, is equal to half mv square. So if I plug in the values, 0.491 equal to half mv square, I will be able to, let me make some space. So this is 0.49, that is 491, let me, yeah, 491. So 0.491 equal to half mv square, which is equal to half times mass is given to me, which is 0.250 v square, and 0.491 velocity value will be equal to, if I do the calculation, so this is velocity square, 0.491 times 2 divided by 0.250. So velocity value will be square root of 0.491 times 2 divided by 0.250, and that value will be 1.98 equal to velocity. One of the things which I wanted to tell you guys, so make sure when you are square rooting this value, so you filing, if you guys are in a habit of filing all the values at once in the calculator, so make sure you guys are filing the values in the brackets, the top values in the bracket and the below value in the bracket, otherwise your answer will be wrong. Okay, so hopefully you were able to understand something about mechanical energy to an isolated system. I'll see you with another question. Bye now.